said before, nothing is perfect in this whole universe. So neither is Rutherford's atomic model. He was the first one, and he was a brave one, and he was a smart one to provide one, to state one model. But there were some loopholes, there were some limitations, there were so many incorrect stuff in his model, and his model was not good enough. His model, it had some limitations. It had really, some big limitations, and we're going to talk about those now. So the first limitation is Rutherford's model did not give any idea about size and shape of the orbitals along which the electrons move. So Rutherford stated that in an atom there are electrons and protons and neutrons, and electrons are revolving around the nucleus, and nucleus is basically proton and neutron. So electrons are revolving around the nucleus, and they're revolving on their own orbitals. But the thing he did, the point he missed here was he never mentioned about those orbitals shape, or he never mentioned how the orbitals are, the orbitals can be in ellipse shape. Ellipse means this is called an ellipse. Okay, they can be oval shape. This is also oval shape as well. You can call it oval shape, or they can be round, circular. They can be of any shape, right? But Rutherford, didn't mention any of it. So yeah, that's the first limitation of his model, that he didn't mention it. Okay, he should have mentioned it. Okay. Next on this model of atom failed to explain the existence of definite lines in the hydrogen spectrum. Okay, this is a very important thing. What is hydrogen spectrum? What is spectrum? Spectrum is basically a bunch of lights or a bunch of rays. Okay, not entirely rays, but yeah, that's what, in easy words, I'd like to call it in that way. So in the atom, if you provided heat, the electrons consume the heat, as heat is basically a form of energy, right? So they consume the heat and they take the energy and they start to vibrate, and they go from lower shell to upper shell, and they don't get to stay there much, and they again return to their own orbital, and then he and the electrons release the energy in forms of spectrum. Okay, so this spectra was explained in Bohr's model, which we're going to discuss later. But in Rutherford's model, there were no mentions about spectrum. But this is something that is created, and this is something we need to discuss, and this is something that should have been mentioned in this model, which was not. So this is also a limitation of this model. Okay. This atomic model failed to explain stability of atoms. So yeah, again, this also failed to explain the stability of atoms. Yeah, that's it. Next one we have, according to Maxwell's electromagnetic theory of radiation. So Maxwell is a well-known scientist. He gave many theories, and in the higher education, if you study electromagnetism, that's a very interesting, quite hard topic or subject. But if you read it, or if you learn it, you understand so many fun facts about science. Like you will start to see this world differently. Yeah, you will see it differently. That's all I can say for now. And yeah, that's it. So that Maxwell gave a theory about electromagnetism, and according to Maxwell's theory, if a charge is revolving around another charge, and if the charges are opposite to each other, say for example at the center there is positive charge, right, and in negative charge electron is revolving around it, and there will be an attraction force, and at a certain point this electron will get attracted to the center and will reach to the center, and the whole process will get neutralized, because you take positive charge, you take negative charge, the whole amount of charge is zero. Okay, the total charge gets neutralized. So yeah, that's what Maxwell's theory was. So let's read it from here, that any charged particle moving in a circular way always emits energy, and its radius will gradually grow smaller. Okay, its radius is gradually growing smaller. We're gonna see a picture. Let's see the picture. See, this is an electron and this is the nucleus. So you can see that it is moving, and gradually its radius is getting smaller, smaller, smaller. It's shrinking. Okay, it's going into the center. That's what Maxwell's theory was about. At the stage, it is supposed to fall on the nucleus. That will be the end of the atom, or at least its permanence will be in trouble. However, that doesn't happen in nature. In other words, according to Maxwell's theory, Rutherford's atomic model is not correct. So Maxwell's theory is correct. So if you Maxwell's theory is actually correct. It's approved by other scientists. So if you apply Maxwell's theory on Rutherford's model, Rutherford stated that electrons which are negatively charged are revolving around the nucleus. Okay, so according to Maxwell's theory, it's supposed to end at the center because electrons are negatively charged, center is positively charged, so there is attraction, and it's gonna shrink into it. It's gonna fall into it, and the whole procedure will be done. There will be no more nothing. So, but according to Rutherford's model, this doesn't happen. Atoms are always, in the atom, electrons are always revolving around the nucleus. There is an attraction force, okay, but the attraction force doesn't lead the electron to fall on the center, to fall in the center with the protons and neutrons. So yeah, so if we want to follow Maxwell's theory, then Rutherford's theory is not correct. We can see in this picture that this picture symbolizes or expresses Maxwell's theory. So if you follow this theory, then Rutherford's theory is not correct. Okay, so yeah, these were the limitations Rutherford's model had. So I'm not saying this is a perfect model, but he was the first person to do it. So he was a great scientist, but then this model was modified. Then after some years, Bohr, another scientist, came with another model, and that model was a better version of this model. Okay, so we're going to talk about it later.